Welcome back. We're studying chapter 17, page 396. Okay, the cylinder. So this is a cylinder. Okay, we're all very familiar with them because it's what our baked beans come in, isn't it? Plus lots of other household items. Okay, so in particular we're going to be studying from page 10. So you can open up page 10 of your tables, and we're going to be studying the curved surface area. So this is a curve. Now, of course, the top and the bottom of the cylinder is a circle, and indeed it reminds us of what we've just been studying in a prism. So it's a type of prism. A cylinder is a type of prism where the circle from the top and the disc, which is the two-dimensional surface, could be the cross section anywhere, and it's certainly the two ends. So what the volume equation for the volume for a prism was equal to the base multiplied by the height. And I'm sure we can find the prism here on the next page that we've been studying back when we studied the cuboid. So the volume of a prism is the base times the height. So we should be able to replace the base with pi r squared, which is the area of a circle, and so we will get pi r squared h for the volume of a prism. So we would need to measure the height. It's like about 10 centimeters. If I measure the radius is about 7, I could work out the volume of this. Let's do it. Pi 3.5 squared by 10. Okay, and we have shift pi multiplied by 3.5 squared multiplied by 10, which is around 384 cubic centimeters, approximately actually 385 if I round up, centimeters cubed, or milliliters, because it's the same thing. So 385 milliliters. Now let's see, do they give the gram, okay, but do they give the volume? Maybe not, okay, but then we could work out the density from knowing our calculation that it's around 385 milliliters, this tin. Okay, so that's that formula. Now what about this other formula, A equals 2 pi r h? Now that's got nothing to do with pi r squared. That 2 pi r h is the curved surface area. If you look here, it says up here, it says A represents the curved surface area. So you want to write that down. Curved surface area. Okay, so I'm going to flick the page over now because I'm going to need a nice big page to take the curved surface area. So if we take off the paper from the edge, then this is the curved surface area. Okay, and I can map that out, draw it out. I'll just extend this a bit. And should come in here at right angles. Just find my set square here. Okay, now we can get the height. It's around 24, But we could have also got that using the radius equals 3.5 centimeters, because we know that 2 pi r, now there might be a slight difference because the way the paper went here it overlapped a bit, so it's okay if there's a little bit of an error, but we're going to use 2 times pi times 3.5 and we get 22 centimeters. So I'll just change that to 22, leaving out the little bit that was, as I said, overlapped. Okay, and the height, of course, should be the height that I measured of this, which is around 10. And so that's the curved surface area. It's 2 pi r h. Okay, so my iPad is running out of charge, so we've time to get on to do a few questions and to do the examples, of course. So from the series of diagrams on the previous page we get these formulas, and if you want the total surface area, you take 2 pi r and you add on the disk, but there's 2 of them because it's at the top and at the bottom, so you have a 2 here. So you can get the total surface area is 2 pi r h, that's this, and plus 2 pi r squared, which is 2 of them. Okay, so let's get on to the examples. Example 1. So find the volume. So here's our drawing. Do we want to draw it? Let's sketch it. Okay, so it's very good to be able to sketch in maths, so that you can kind of, instead of it being in your book, or worse still, even on a screen like you have and I have here, I'm going to draw it out. Okay, so I'm going to have that the diameter equals 14 centimeters, so the radius equals 7 centimeters, and let's use the letter R for the radius. Okay, and the height is 24, we don't have to do anything with that. Okay, the height is 24. Height equals 24 centimeters. So don't make the mistake of having that as well. You don't need to, and you shouldn't have that. So find the volume and the total surface area. Okay, so for the volume we're going to use the formula for volume, which is the area of the base times the height. And now we won't take pi equals 3.14, we'll take pi from our calculators. Okay, because that's what we're doing now, because that's the way it is in the exams. Now the calculators are everywhere. Okay, so we're going to go equals pi multiplied by, we're going to replace r with 7 and square it, and we'll replace the height with 24. We'll put that in our calculator and use shift equals to get the answer, to get directly to the exact answer without pi in it. Okay, so you go shift pi. On the newer calculator you'll get pi slightly differently. You'll get pi with shift 7, okay, multiplied by 7 squared now multiplied by 24, and we can do shift equals, and in this one I'll do equals to give the answer in terms of pi. So we'll always write that down as well. It's a very good habit, 1176 pi, because it's exact, whereas this I'm going to have to round, which is, and that's centimeters cubed, and then this next one is 3694.512 dot dot dot, and then we're going to round it up, and we get 3695 centimeters cubed. Yes, my answer is slightly different than it is here, but that's because they used a rounded version of 3.14. Okay. So next we're going to get the surface area, the total surface area. So we write TSA for total surface area, and we write curved surface area CSA, curved surface area plus the 2 plus the ends. Okay, and we have that the total surface area equals 2 pi r h plus 2 pi r squared. So if you look at this carefully, you see they're both 2 pi. They both have an r in them, but this one has RH and this one has r. You could even do a very fancy piece of maths and factorize out 2 pi r, giving h plus r. Okay, it's a cool thing you could do. Right. And so we can fill them in to either this one or this one. Okay. So, and by the way, 2r is the diameter, so I could use 14 for the diameter. Okay, then I have times pi, and then I have times the radius, which is 7 and 24. So 24 for the height and 7. Okay. And you can do it either this way with substitution or this way with substitution. Either way, we're going to get 14 by shift 7 by 24 and 7 I can do in my head, and I get 31. Okay, so I get 434 pi, and then when I want it exact I can do shift equals, which is equal to 1363. I'm looking at that and it's going to round down, so I leave it at 1363 centimeters squared, because that's area. Okay, and ignore the fact that we're slightly different to them, because that's what we're doing now. We're doing calculations using the exact pi. Second question is that the volume of a cylinder, again I'm just going to sketch a cylinder and say the volume of it equals 1232 centimeters cubed. Okay, if its height is 8, find the length of the radius, and we'll use an exact pi. Okay, so we write the formula for volume equals pi r squared h, and we'll fill in what we know, which is 1232 equals pi. We don't know r squared because we're trying to get it. Okay, so pi r squared, but we do know 8. So we'll write this as 8 pi r squared equals 1232. So let's divide down the 8 pi. So the way we do this, it's called algebra. You know about algebra. Okay, we are doing the opposite to multiplying by 8 pi. So we will divide down the 8 pi factor. Okay. And we'll round that to 49. Now if r squared equals 49, now our next problem is, and let's write it again, r squared equals 49. What could r be? So a square of a number is 49. So some of you might recognize that by inspection. You might remember, oh, I know a number that's squared is 49. You might remember it's 7 squared. But if you don't, what you can do is, and I want you to write this anyway, so we're going to do the inverse operation of square to both sides. And the reversing of squaring is square rooting. So when you square root r squared, you get r, and when you square root 49, you find out in the calculator what it's worth. So you get the square root of 49, r equals 7 centimeters. Okay, that's the second example done. So we're going on to the exercises, which I'll do in a separate video. would be suggesting that I'll give you the even numbers 2, 4, 6, 8, and 10 for homework. We'll see about that later on. Okay, as always, I will see you in the next one.